If you've ever played Mario Party, or Pummel Party if you're like me and you don't want to pay over $400 to play a single game, Jesus Christ Nintendo, you know how much fun they can be. When I used to live near my friends, I had a whole setup where we would get together and play Pummel Party in a shared screen, and it was always a blast. But after everybody moved away, we couldn't really keep playing, since one friend only owned a PlayStation and a couple others only owned MacBooks. So I had two options. I either make my own party game in Unity, in which I have over 5 years of experience and dozens of completed projects under my belt, or I can just make this game that works in a browser window and anything that can open a browser window can play. I was particularly excited about the second option because every day I see these amazing creations made with Three.js, which is a 3D library where you code in JavaScript to render 3D things on a browser window. And this actually isn't my first rodeo with Three.js either. I did use it for some small side projects here and there, but somehow even those smaller projects felt much more difficult than they should have been, since I always found vanilla JavaScript really hard to use when you need to maintain a state or do object-oriented programming as you often need in game development. But then my prayer sort of got answered when I found out about React 3 Fiber, which is a React wrapper over Three.js, allowing me to use familiar React syntax. So let me take a step back. This game will consist of a front end, so the client or the browser window that the user will see. And then there'll be a backend, the server, that will communicate with all the clients and make sure that everything is in sync. Usually websites communicate using REST API requests, so you can get a user's page, or you can sign up as a new user, or update or delete your profile, etc. But video games are a little different. You need constant communication between the client and the server, which is why it is much more common to use WebSockets, which offer a constant two-way low latency connection for instant updates, unlike REST APIs, which are slower due to their request response nature and higher overhead per message. Specifically, I will use Socket.io, which is a very standard WebSocket framework that is commonly used in multiplayer browser games. Right off the bat, I wanted to use TypeScript for both the front end and the back end. Since JavaScript isn't statically typed, you can do some crazy things that you wouldn't be able to, say, using a language like C#. By using TypeScript, we can define a player type which has a name field. So if our function incorrectly tries to assign or modify the player name field, the code wouldn't even compile, and I would catch this error before anything breaks. But I didn't want to define every type twice, once for the client and once for the server, so I opted into having a shared node package that would contain the types instead. With the infrastructure in place, I started off with a simple game board, and then added in synced movements and rotations between the players. I added in the code to handle different game views, so this would be seeing the game board versus the mini games that the players would participate at in Pummel Party. And I know I shouldn't focus on the visuals this early on, but I couldn't help myself. I found this cool grass shader online and I wanted to add that to my game, which actually kind of worked off the bat. The plan was to generate an uneven plane, put the grass on it, but for some reason the plane's physics wasn't working properly. The player randomly dipped and climbed without any rhyme or reason. While debugging, I somehow did this. And somehow while I was testing things out, I also broke the camera. The project wasn't going really well, because I couldn't even fix the bug that was on my mind, and as I was trying to fix it, I found 3 more bugs and broke 8 more things, and that's where I reached a point where I was seriously considering going back to Unity. Or maybe just start organic farming. And I'll be the first one to say that I really underappreciated all the heavy lifting Unity does. When I first saw Three.js and how easy it is to render 3D things on the screen, I thought amazing, this can replace Unity. But as you work with Three.js, you realize that it's just a 3D renderer and not a game engine. So you don't have access to things like having scenes or having a built-in editor and the physics, the colliders, and so much more. But I was dedicated to having this project work on a browser window, so I got back to solving the problems one by one. The first thing I figured out was how to set parent-child relationships in the context of Three.js, which turns out to be a pretty trivial task. And that jitter was happening due to some old code which forced the player to be at least as high as the radius of the sphere, so the player's mesh, and this kept fighting with the gravity that was pulling the player down now that we were using actual physics and rigid bodies. And that mysterious plane? Well, turns out it was because the player that we see and the player's rigid body that the physics interactions happens on were in completely different locations. What an odd bug. And during this process, while I was testing in multiplayer, I came across this funny bug where the remote player was spinning like a Beyblade purely off of the physical interactions. And a simple fix here was to make the rigid bodies unrotatable if you're not the player piloting it. With the basic physics down, I moved on to adding some color to the free play scene. And it is kind of hard to notice, so you might have missed it, but the whole grass plane disappears randomly all the time. And this bug was a result of something called frustum culling, or the lack of it. Once I set that to false in the mesh component, it prevented the grass field from being culled away when the camera thought it was out of the screen. Continuing on this free play scene, I kept referring to that bottom flat layer as the sea level. So speaking of the sea level, I decided to add some water. And right off the bat, it wasn't looking terrible, and the water and grass looked nice together too. I moved on to some quality of life upgrades, such as not letting users fall off the map by adding some invisible corner walls, stopping the camera from clipping the water, which was due to those corner walls, and instead of the map abruptly ending, slowly leveling it off just by extending the plane. And at this point I realized the game was becoming increasingly laggy, even with very few objects on the screen. My laptop fan sounded like it was about to take flight, and the Chrome kept warning me about excessive battery usage. But hey, insert Chrome joke here, am I right? It was time to dive deeper using the performance profiler. Turns out, the grass rendering was the culprit. I mentioned previously I disabled frustum culling to prevent the grass from disappearing, but the trade-off was huge because now the entire grass field was constantly rendered, even the parts that were not visible on the screen. Clearly, I needed a better long-term solution, but for now I just reduced the number of grass blades and I moved on to tackle a different kind of optimization, optimizing my code base. I realized all of these issues I was having were getting harder to solve since I was moving with a lot of speed and not really thinking about the code. So I started by modularizing the types into multiple manageable files, and similarly organized all socket events with clear types and definitions. Next, I wanted each game mode, so for now the board and free play, to have clearly separated logic and data management. I first successfully got the board state to persist across different sessions, but of course something broke again where the free play physics went completely haywire when the multiplayer data started syncing. Then I was faced with this baffling bug where one player randomly lagged. At first I thought it was the host that was lagging, so I switched which browser window was the host and the same window kept lagging. Then I tried using Chrome versus Safari and still that same browser window was lagging. Eventually I just restarted Chrome entirely, and would you believe that it fixed itself? So therefore it's my scientific conclusion that this might be a memory leak, or perhaps Chrome was simply fed up after being open for 2 weeks straight, I don't know. So after all the performance fixes, let's take a checkpoint here, rest up and see where we are at now. The board mode was looking smooth, but the free play was struggling. Buggy interactions, broken physics and multiplayer jittering made it unplayable. I decided to slow down and tackle each issue one by one. Free play mode actually didn't look terrible when playing solo, and I know it looks laggy on your screen right now, but trust me. Okay, if you don't believe me, here, I'm gonna open the same game on a Safari window and it's not gonna have any lag. Remember, Chrome tabs get bored and they lag, so we need to restart them. Multiplayer on the other hand looked really bad. The remote players on each screen looked possessed by gravity, constantly snapping back and forth. I temporarily patched it by disabling gravity for the remote players, but it was effective enough for now. Also, another silly bug, I noticed the maps looked completely different across clients, and I realized this was happening because each player had their own random seed. And I was able to solve this by using the room ID as the seed for the noise generation, and since everybody had the same room ID, everybody would have the same random map generated by the noise. Finally, things began to stabilize. Everything was working smoothly, and for the final test, I wanted to see how this would hold up in the production environment, so using the hosted front end instead of my local dev window. And let's just say that things weren't looking so good, which is weird because 4-player tests in local looked fine. And I knew the problem wasn't something too bad either, because if you notice, the rotations actually looked really smooth. It's just the positions that were all over the place. The problem was actually about the communication between the client and the server. And it's kind of insane that the solution was an actual one-liner. More specifically, the problem was that the server was sending the position of the local player back to them, which caused the local player, and therefore the camera, to jitter like crazy. So if you imagine you move to the right, and then you tell the server, hey, tell everybody else I moved to the right, but then the server would tell your client back that you moved to the right, but at that point you probably would have moved even further, so you would teleport back and you would just start to jitter forever. So the fix was to just stop doing that. I changed the code so that the server would only notify the other clients about your movement, not your client itself. And the result was instantly way smoother gameplay. Feeling confident, I ran one final test and discovered a regression. The board positions were no longer being synced up properly when switching game modes. And I was able to pinpoint this issue by actually comparing my past commits. Turns out, during the recent refactor, I made a mistake. I was updating the player's board position when this specific event was emitted when the player moved in the free play mode. After fixing the regression, I ran another test in the production environment, and this time everything held together pretty well. It felt like an honest day's work, but realistically it took 3 weeks and things weren't perfect, but now the game was stable enough to genuinely have fun. Now the core pieces are in place, we have the physics, a persistent game state and a smooth multiplayer, and now I am free to move on to building out the content for the game. What do you think? Would you be interested in a free-to-play browser-based party game to play with your friends easily? Let me know in the comments down below. Thanks for watching. Hope to see you next time.